Okay, in the last topic we have seen the set theory notation and set representations. If I mention the set theory and set representations in a statement wise or in this particular form, sometimes it is very difficult to imagine. So in order to imagine, our best way is to our way of thinking, the best way is to draw some diagrams, representations, notations, so that we can easily understand what the particular statement is trying to say. So in the same way, here we are going to see in this particular topic the Venn diagrams, that are used for representing the set theory or set representation, and we are also seeing the operations on sets, principles of inclusion and exclusion. So Venn diagram, a set can be visualized using Venn diagrams. In a Venn diagram, a rectangular shows the universal set, that means which consisting of all elements, which is a universal set. Okay, and all other sets are usually represented by circles within the rectangle. The shaded region represents the result of the operation. Let v is equal to a comma b comma c. Then you want to represent this particular set v is equal to a comma b comma c under the universal set. There may be any number of elements, but you have to figure out only a, b, c. Okay, it is just like the best example is you are looking into the sky and you want to figure out the moon. Okay, there may be several stars, maybe several things may be there. You want to particularly point out moon. So whatever the stars available over there are the universal set in which you want to represent one particular set, that is moon. It's just like that. A best example is if you look at your Janma Kundali. Okay, that is a representation of the set in the universal set, where Rahu is there, where Ketu is there, where Jupiter is there, where Mercury is there, where Mars is there. That is what the representation, right? So you can correlate anything. What will happen in our natural or daily life, that you can also represent in terms of the Venn diagram. For that purpose, I have given your Janma Kundali example. Okay, a subset A is said to be subset of B if and only if every element of A is also an element of B. And the representation of the subset is like this: A subset B. Okay, so here look at this one, and under this one line should be there. Okay, this is said to be subset. If line is missing, then it's said to be the proper subset. Okay, that we'll see afterwards. To indicate A is the subset of B. Now this is the universal set under which several points are there. Okay, A is the representation and B is enclosing A. So that means A is the subset of B. While coming to the subset properties, these are the properties that you are supposed to remember. Always the null value, whatever the null value is there, null set is the subset of S. Okay, empty set is the subset of any set, and every set itself is the subset of that particular set. S is the subset of S. So any set S is the subset of itself. Alternate way to define A is the subset of B. Here this symbol represents the for all. For all X that is available in, which is belong to A, is also available in B. Okay, this is another representation to say that the is another way to define A is the subset of B. Now we'll see the proper subset. A set A is said to be the proper subset of B if and only if A is belong to B, that is A is a subset of B, and A is not equal to B. If these two are satisfied, then we can say A is the proper subset of B. We denote that A is the proper subset of B with the notation A subset, that is proper subset B. So if you mention a line below this, then it's said to be subset. If you won't mention the line, then it's said to be proper subset. Here example, A is equal to 1, 2, 3, B is equal to 1, 2, 3, 4, 5, and A is the proper set of B or not. So A is the proper subset of B. So we'll see some more set operations. Let A and B are the sets. The union of A and B denoted by A U symbol, okay, union symbol. B is the set that contains those elements that are either in A or in B or in both. So here A union B is shaded totally, the entire these two circles along with the joining, all the everything was shaded here. So example here, A is equal to 1, 2, 3, 4, 1, 2, 3, 6, and B is 2, 4, 6, 9. A union B is equal to 1, 2, 3, 4, 6, 9. Okay. While coming to the intersection, let A and B be sets. The intersection of A and B is denoted by, intersection is the upside down of the U, that symbol you are supposed to use. So this is the symbol you are supposed to use. Intersection is a set that contains those elements that are in both A and B. And this can also be represented in the set representation like this. A intersection B is equal to X, where X belongs to A, and this particular intersection X belongs to B. So here, whatever the shaded region is there in between A and B is the intersection. A is equal to 1, 2, 3, 6. B is equal to 2, 4, 6, 9. So whatever the common elements are there, that will fall under the intersection 2, 6. Set difference. Set difference is represented with the minus symbol. Let A and B the sets. The difference of A and B denoted by A reverse slash, that is not the forward slash, backward slash B, or A minus B. So you can represent in two ways. Is a set containing those elements that are in A but not in B. The difference of A and B is also called as the complement of, B with respect to A. That means A minus B is nothing but which are present in A and not in B. So example here, A is equal to 1, 2, 3, 4, 5, 7, and B is 1, 5, 6, 8. So A minus B is 2, 3, 7. Okay. So elements that are present in A, not in B. Let A is equal to A comma B comma C and B is E, G, F. Then what is meant by A minus B here? That are present in A and not in B. So A minus B is equal to A set only. Okay, that is A, B, C, because there is no common elements in this. Complement. Complement means 1 minus anything. Okay. So here definition, let U be the universal set, the set of all objects under the consideration. The complement of the set A denoted by A is the complement of A with respect to U. The complement is represented with the bar symbol on the top of the set notation, or with a suffix of small c. Okay, these two will be represented for the complement set. Now, what is the A complement? Except A, everything. Okay, so in the universal set, wherever the A is drawn, A dash is the shaded region. Means this is the region where A complement represents. Example, U is equal to 1, 2, 3, 4, 5, 6, 7, 8. A is equal to 1, 2, 3, 4, 1, 2, 3, 5, 7. Where A complement means, so here 1, 3, 5, 7 is available in the universal set. And complement means without this 1, 3, 5, 7, whatever the elements are there, that is 2, 4, 6, and 8. These are the complement of the set A. While coming to the symmetric difference is nothing but the symmetric difference of two sets A and B is the set of all elements which belongs to exactly one of the two original sets. Okay, this operation is written as A with a triangle symbol B, or A with an exclusive operation kind of thing, plus with a circle over that B. In terms of union and intersection, the symmetric difference of two sets A and B can be expressed as A symmetric difference B is equal to A union B minus A intersection B. So combine A set and B set and take out the common one, A intersection B. So here the examples are like this: A is equal to small a b c, B is equal to small e f g. The symmetric difference of two disjoint sets is equal to their union. So it is just like A union B minus A intersection B. Is there any commonality is there? No common element is there. So since there is no common element, it is null. So A union B is equal to A, B, C, E, F, G. So this is what the set difference or symmetric difference. C is equal to, another example, C is equal to 1, 2, 3, 4. D is equal to 2, 4, 6, 7. And what is the set difference? C union D minus C intersection D. Any common things are there? 2 is common and 4 is also common. So remove 2 and 4 from the set 1, 2, 3, 4, 6, 7. So whatever the result you will get is 1, 3, 6, and 7. The membership relation, already we come across the membership relation. How we will represent the membership? That is belongs to. So let A is the set under the let A be the set and let X be the some object. Notation X belongs to A. That means the element X is belong to the set A. Meaning that is X is the member of A. That is what the meaning. If it is not the member of A, same belongs to with a strike off. Okay, that is what is called not belongs to A. So here is a simple example: V is equal to A E I O U. E belongs to V and B is not belongs to V. Equality of the sets, when you can say both the sets are equal if both elements are common. Two sets A and B are equal, denoted as A is equal to B if they have the same elements, otherwise A is not equal to B. So here usually this is the representation, and if you strike off the particular is equal to is B. So in case of mathematics, you will represent two equalities. That is, if you want to equal two sets, you will represent simply is equal to symbol. Okay. In case of computer programming, is equal to cannot be considered as the equal to. Is equal to is used as a assignment operator. Okay. If you say integer x is equal to int x is equal to 10, that means it is not, you are not equating here. You are not checking for the equation. You are going for assigning of 10 to the variable x. In programming, you will use double equal to for representing the equality. Okay, that you are supposed to remember here. Example: set A of odd positive integers is equal to the set B of prime numbers. A set of odd integers between 4 and 8 is equal to the set of prime numbers between 4 and 8. So between 4 and 8, 5 and 7 are the prime numbers. While coming to the odd integers also 5 and 7. So both are same here. So we'll see finally the principle of inclusion and exclusion. What is this principle of inclusion and exclusion? The idea of this particular inclusion and exclusion is ignore duplicates at first and include all objects. After including all objects, then exclude the duplicates. Okay, irrespective of what type of elements are there, either maybe common elements or maybe duplicate elements, you try to include all the elements, then look for what are the duplicate elements and remove those duplicate elements from them, which is called inclusion exclusion principle. Okay, here is the example. The number of multiples of 2 or 3 in 1 comma 20. So 2, 4, 6, 8, 10, these are the elements that you will get. So 2, 4, 6, 10, 12, 14, up to 20 you will get. And I'm taking another set which is the multiples of 3 between 1 and 20. So 3, 6, 9, 12, 15, 18 you got. Now, according to the inclusion and exclusion principle, first you include all elements. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 and comma 3, 6, 9, 12, 15, 18. After including all the elements, now you check for the duplicates. Remove those duplicates. So the expected answer is not 16 here, because in the first set we have 10 elements, in the second set we have 6 elements. The total cardinality is not 16. Because we are going to remove them, subtract the common elements. So three elements are there which are common. So you are removing those 3 elements, so that the cardinality will become 13. So this is the famous this is the famous formula that you have already studied. Okay, that is what come under the inclusion and exclusion. Now you can understand what is my inclusion and exclusion. A union B is equal to A plus B plus A plus B minus A intersection B. Right? This principle already you have studied. Okay, which is also called as inclusion and exclusion principle. Here 2 sets are there, A and B. If 3 sets are there, then the formulation will be like this. A union B union C is equal to A plus B plus C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. If 4 sets are there, the formula was given there. A union B union C union D, just like A plus B plus C plus D minus A intersection B, combinations of. Okay, A intersection C, B intersection C, A intersection D, A intersection B intersection C, and addition of them, plus A intersection B intersection D, B intersection C intersection D, minus A intersection B intersection C intersection D. Here is the Venn diagram that represents this particular inclusion exclusion. And if more than 4 are there, then how you will calculate? So here is the formula for you. If more than 3 or 4 are there, so formulating is very difficult. You are supposed to remember this generic formula, or you can make note of them. A1 is the set 1, union A2, union A3, and so on up to AN. Then this particular formula is used for inclusion and exclusion principle. So here is the simple example. Just by looking at the calculation, calculate the number of multiples of 3 or 5 from 1 to 500. Let A be the set of multiples of 3 from 1 to 500. How many multiples will be there? 500 by 3. Let set B be the multiples of 5 from 1 to 500, how many multiples will be there? 500 by 5. So 500 by 3 is 166, that is the cardinality, and 500 by 5 is the 100. See, in the mathematics, wherever this particular symbol is there, this particular representation, this is said to be lower bound. Okay, this is said to be the lower bound. If the same is represented in the top, this particular line is represented at the top, then it's said to be upper bound. So 500 by 3, you may get it as maybe 166 point something something. Okay, now you are supposed to take the lower bound. So you are supposed to take the 166. If you represent as upper bound, then you are supposed to take it as 167. Okay, I hope you got clear in this. Next is 500 by 5 is 100. So A intersection B is 500 by 15. That is 33. Now the number of multiples of 3 or 5 is A union B is equal to A plus B minus A intersection B. It will come up to 233. Right? This is the way of representing the elements.
We'll see one more example related to inclusion and exclusion with respect to the representation of a problem in the computer science point of view. A large software development company employs 100 computer programmers. Of them, 45 are proficient in Java, 30 in C Sharp, 20 in Python, 6 in C Sharp and Java, that is combination C Sharp and Java, 1 in Java and Python, 5 in C Sharp and Python, and just one programmer is proficient in all three languages above. Determine the number of computer programmers that are not proficient in any of these three languages. Now we need to consider the total number of employees are 100 and 45 are proficient in Java. J is equal to 45 and C Sharp is 30, Python is 20. Like that we need to consider. So let U be denoted as the set of all employed computers. This is the universal set. Let J and C and P denotes the set of programmers of proficient in Java, C Sharp and Python respectively. So here the universal set is 100, J is 45, C is 30 and P is Python is 20. And J intersection C, that means having both knowledge in Java and C Sharp is 6 and J intersection P is 1, C intersection P is equal to 5 according to the problem statement. While coming to the proficient in both Java, C Sharp and Python is 1. Now determine the number of computer programmers that are not proficient in any of these languages. So how you will consider? That is we need to determine the cardinality of the complement of the sets J union C union P. This denotes as J union C union P complement. That means the whole of J union C union P complement. That means the number of programmers minus this one. So here J union P, let me calculate 39 plus 5 plus 20, because J union C union P is equal to J plus C plus P minus J intersection C, J intersection P, like that. We have already seen that particular formula. So 39 plus 5 plus 20 plus 4 plus 15 plus 1 is equal to 84. Now calculate the complement. Complement will be calculated as universal value, that is U minus this J union C union P, which is 100 minus 84 is 16. 16 programmers are not proficient in any of the three languages. So this is the way how we will use the inclusion and exclusion principle for formulating and solving the real world problems. And here are the exercises given. A is equal to 2, 3, 4, 5, 6, 7 and B is equal to 0, 1, 2, 3. List the elements of the following set: A intersection B, A minus B, B minus A, and the difference A triangle B, set difference. Sorry, symmetric difference of A and B. Let universal set B u is equal to x belongs to n, that is natural numbers, and x is less than or equal to 10, its subsets A and B are given by A is equal to x of x is even, and B is x belongs to n, x is lies between 4 and 9, that is 4 is less than or equal to x is less than 9. Find the following set: A union B complement and B A intersection B whole complement, A minus B whole complement. So you need to expand the values which are available there, then you need to perform this. Like that, find the elements of the set A and B. If A minus B is equal to A comma B comma D, A intersection B is equal to C comma E, and A union B is equal to A B C D E G. Now you can apply the formula of A union B is equal to A plus B minus A intersection B. So this kind of formula, whatever is available, that you may use and get the values. Like how I have given the program like this, problem statement like this. So you are supposed to go through this. In a foreign language spoken survey taken out of 100 students, 45 students learn Spanish, 28 spoken French, and 22 spoken Japanese. 12 students learn Spanish and French. So these are the combinations you need to make use of. And finally, you have to calculate how many students learn these languages. So these are the exercises for your practice, and we'll see the rest of the concepts in the next lecture.